Hi friends, welcome back to Padhiye with Prachi with chapter 1 of class 10th NCERT CBSE maths book. The chapter is real numbers and we are going to proceed. We have done till exercise 1.1 in our last class and we are going to proceed further. So let's get into it. Okay, so it's the next thing that we have specified is that we're going to learn here is theorem 1.2. It says that let p be a prime number if p divides a square, then p divides a, where a is a positive integer. So first let's try to understand what it means. So we can take it by an example. So if let p be a prime number, so if we have taken that p is equal to 2, 2 is a prime number. If so let's take 3 for example. I don't know why I'm taking 2 or 3, anything, you can take anything. Let's take p is equal to 2. So if it is dividing a square, right? So you can take any number a as probably 6. So if it is p is dividing a square, what does it mean? That this equal to 18, right? With a remainder of 0. It's completely divisible here. So if it is dividing a square, what does it mean by it's dividing a square? That if 2 is dividing 36, that means 36 divided by 2 is a number, it's not a fraction. Then p divides a as well. So what is a? 6, which we know 6 divided by 2 is equal to 3. So these are very small numbers, like it's a very, so let's, for example, if it could have been a bigger number, right? So if so let's just take an example. I'm just trying to see 169, 29, 218, 2 6 12, 13, 2 1 2 3, right? 2 9 18, 2 6 12, 13, 2 1 3. So let's take a big number, right? 338. At this point in time, we don't know, right? So I know this because I've taken this example from my mind. So 338 square. So for example, the question is the assumption is, or we know for a fact that 338 square, so we have to first find out what is that, obviously, is divisible by 13. So then 338 is also divisible by 13, which we know for a fact because 169 itself is 13 square. So what does it really mean? So let's get into that. Mean here. If we just look at alphabets, right? So it means that a number a square divided by p, it's completely divisible. When will it be completely divisible? If in a square, in a itself actually, right? If we look, if we, how do we express? A itself is p1, p2, p3, pn. One of these prime numbers, this is following from the previous theorem that we had said, right? So one of these numbers is p itself. We have said p is a prime number, then only p divides a square. This concept where we say p divide a square. So it is quite obvious that p will divide a also. It is quite obvious because a square itself is a to the power 2. Just we are first, what is a? A is p1, p2, pn. Multiplication of prime numbers, product of prime numbers. What is a square? Right? So a square is this. So it is quite obvious that if this is able to divide p, it means that so this is obviously repeating. So one of this number is p, then only it will be dividing when it becomes a square. So it's obvious that a is dividing p. So what this theorem is basically used to prove is that, where is this coming from actually? We have learned that p, an irrational number, cannot be expressed as p divided by q, where q is not equal to 0. It cannot be expressed like this. These are integers. So how do we prove that root 2 is irrational. How do we prove it? So what we do is by first trying to contradict it. Prove root 2 is irrational. That root 2 is irrational is first by taking the assumption that it's actually rational. So if it is rational, it can be expressed as a division of two integers where b is not equal to 0. So what is this? Root 2b is equal to a. If we just square on both sides, what does this mean? So what are we telling here? So this is the question, that we have to prove that this is irrational. But to prove root 2 is irrational, we are going to first start from the opposite direction. We will take the assumption that root 2 is actually rational. So if it's rational, it can be expressed as a division of a by b, where b is not equal to 0. So we can express it in this manner. We can square on both sides. So what does this mean? That 2 is divides a square. So 2 divides a. So that means what is a? A is equal to 2c, right? A is equal to 2c. So if we put a is equal to 2c here, and then we square, what does this mean? 2 divides b square also, right? So 2 divides b square, so 2 divides b also. So what does it mean? That 2 divides a and b both, but the assumption actually, which I forgot to mention, was that these are co-prime. So then if 2 divides a and 2 divides b, this assumption becomes false, and hence that first assumption that root 2 is irrational is false. So we'll proceed to the next question. So these questions are a little bit different. They're not your usual questions. We sort of go ahead basis taking the assumption that it's actually false, and then we come back to it, right? Okay. So now moving on to the next concept. In class 9th, you have already studied that sum of two irrational numbers is irrational, and product or a quotient, that is division of a irrational number and a number, non-zero number, is also irrational. So this whole purpose of the second part of the chapter is around irrational numbers, right? So these are the examples that we are going to proceed to. So this is sum of two numbers. One is irrational and one is not an irrational number. So it is irrational. So how do we start these questions? As we did with previously, we are going to first make the assumption that this is actually rational, and then we are going to disprove it. So 5 minus root 3 is irrational. So we are first saying that it is rational. Now, if it is rational, then it can be expressed as a by b, where a and b are co-prime and b is not equal to 0. So we are just rearranging here. 5 minus a by b equal to root 3 is equal to this. Now, if we just look at this number, right? 5a and b, we have already said that a and b are co-prime integers actually. A and b are co-prime integers. So 5a and b are co-prime and integers. So obviously this is a rational number. But we already know for a fact that root 3 is not rational. So that means this is wrong. That means the first assumption is wrong. That means this sum of irrational and irrational, or irrational whatever, is irrational. Basically, if an irrational number is present, if you add something to it, that is also a rational number. Now next is product of two numbers here. One is irrational. So again we specify that it is, so first we go ahead with the assumption that 3 root 2 is actually rational. So if it's rational, it can be expressed as a divided by b, where a and b are integers and b is not equal to 0. So what is root 2? Now this is integer, this is integer, this is integer. So this number has to be a rational number. It can be a fraction, right? Kuch bhi ho sakta hai. It can be a fraction. So it's a rational number. But that's wrong because this is irrational. So this is irrational. So this is the concept which is being taught in the second part. I'll probably explain one or two more for this. So we're going to exercise 1.2 of NCERT textbook. First question is prove root 5 is irrational. So we'll go with the assumption. How do we proceed this? We go ahead with the assumption that it's actually rational. So if it's rational, it can be expressed as division of two integers a by b, where b, they're both co-prime and b is not equal to 0. So you have to specify that. When you write in your school, you have to specify a and b are integers, co-prime integers, and b is not equal to 0. This is how you're going to start. So we first assume and if it is rational, then this, now what we are going to do is squaring both sides. I'm actually telling you how you should write in your answer sheet. Squaring both sides, 5 is equal to a square by b square, rearranging 5b square is equal to a square. It means 5 divides a square. It means 5 divides a. This is how you have to write. Right? 5 divides a. हमको पता है. We know what we have to do here. 5 divides a. So what does it mean? A is equal to 5c. A can be, so you can write before this, a can be expressed as a equal to 5c. So if a equal to 5c, then a square is equal to 25c square. Now substituting value of a in 1. What is 1? This is 1. यहाँ पे when you are writing in your answer sheet, you need to specify ... 1. When you are substituting the value of a square in 1, it becomes 5b square is equal to 25c square. We just so it becomes b square is equal to 5c square, which implies 5 divides b square, which also implies 5 divides b, right? So this is how your answer sheet will look like. It's a little untidy here, but we also have it present here in the example, right? Here it's written as step by step in the theorem, under theorem 1.3, root 2 is irrational. So you have to follow this, because that's how you have to show, because in your mind you might have gone ahead, but in your answer sheet, in your class exams, you have to show it in this manner, right? So now, so this is the turning point. You can probably make it like this. Now 5 divides b, you can see, you can probably put this 2 and put this as 3, and you can say from 2 and 3 we see that 5 divides both a and b, which is against our original assumption that they are co-prime, a and b are co-prime numbers, integers, and hence our original assumption is false and root 5 is an irrational number. That is how you have to write. I have not specified the last 2 lines, but that is how you have to write in your exam. Okay, so these are the next 2 questions that I'm going to solve, and that would be the end of this chapter. Okay, we are going to also summarize as to what we have learned so far. So the first question is prove that this is irrational. So we had already learned, as I told, and I had explained also previously, what is it? Is that of sum of an irrational number. If you take an irrational number and you add something to it, it is irrational. And if you take an irrational number and you multiply or divide something into it, it is irrational, right? That is the thing. But so this is something which we know, but how do you know is through these examples. So we have to prove that these are irrational numbers. And how do you approach this? As we just did with root 5, how we approach is, first we consider it as rational. So first is, so I'm going to solve both together, okay? Okay, so what are we saying? First, we are assuming it is rational. That means it can be expressed as 3 plus 2 root 5 equal to a by b, where this. So this is the first assumption. So now what we do here is, so we rearrange. How do we rearrange? We try to bring root 5 on one side, right? So it becomes by 2 a by b minus 3 by 2. This is what it becomes if you arrange. I am doing both of them together. Now, the answers of both of them will be like literally same in that same fashion. We know a, b and 7 are integers. So you're going to write we know and therefore hence and our assumption is incorrect. Similarly here, we know 2, a, b, 3, 2 all are integers and hence this expression becomes a rational number, and we know that this is irrational and hence our original assumption is incorrect and therefore it is a rational number, irrational. So summarizing chapter 1 of class 10th CBSE NCERT maths book, real numbers. Summarizing this chapter, so the first thing which we learned was fundamental theorem of arithmetic, which we already know from our previous classes when we did LCM, HCF, etc., is that every composite number can be expressed as a product of primes, and these factors are unique. The order is not unique. You can mention in any order. So P is equal to P1, P2, P3, Pn, where these are prime numbers, product of primes, and they're mentioned in ascending order. The next thing that we learned, there's one more associated concept that we learned, was that for LCM and HCF, right? You can find it out by this method. I think we already do. You already did in your previous classes, right? If there are two numbers, just two composite numbers, then the product of the LCM and HCF is equal to the product of the two composite numbers. That's an associated concept to this. Before going on this, the second concept we learnt was, if P divides, where P is a prime number, divides A square, then it follows that P divides A as well, right? So we use this to prove that root 2 or any example, right? Root 2 is an irrational number, right? And then following this, we also proved the other concepts, which was that if an irrational number is subtracted or added to another number, it remains irrational. If it's divided or multiplied, it remains irrational. Previous class was that, not previous my class, in your previous class, was that a number is irrational if it cannot be written in the form P by Q, where P and Q are integers and Q is not equal to 0, right? So these are the concepts that we learned in chapter 1. Hopefully you understood it, you got it. And if there is anything else that you want me to cover, you can mention in the comments below and I can explain them further. We can take it up during the live session, or we can take it during the comments, or I can probably record on the video for it. We can see how it goes. Till then, like, share, comment and subscribe to my YouTube channel, Padhiye with Prachi.